So we will see some questions. Judge the equivalent resistance when the following are connected in parallel. So this is 10 to the power of 6 and this is 10 to the power of 3 and this is 10 to the power of 6. So all parallel connections he has made. So that means 1 divided by R is equal to 1 divided by 1 plus 1 divided by 10 to the power of 6. We take this as a LCM 10 to the power of 6. So 10 to the power of 6 plus 1. So it is nearly equal to 10 to the power of 6 divided by 10 to the power of 6. So that means it is equal to 1. So that is 1 by R is equal to 1. This one. And here you see 1 divided by R is equal to 1 divided by 1 plus 10 to the power of 1 divided by 10 to the power of 3 plus 1 divided by 10 to the power of 6 is equal to 1 divided by 1. No. Here LCM will take 10 to the power of 6 is equal to 10 to the power of 6 plus 10 to the power of 3 plus 1. So if you simplify this, you will get approximate 0.9 ohm. So meaning of this is, in both the given cases, the equivalent resistance is less than 1 ohm. Okay. So that means what? Equivalent resistance in parallel combination of resistor is always less than the least resistance of any resistor in the circuit. See, here we have used, this is the least resistance. That means we have to get less than this resistance. So 1 and 0.9. So this is the judgment. So here just to see, an electric lamp of 100 ohm and a toaster 50 ohm, water filter 500 ohm are connected in parallel to the 220 volt. What is the resistance of electric iron connected to the same source that takes as much current as well as 3 appliances? So what is the current through it? So this is the question. So what he has given? R1 he has given, R2 he has given, R3 he has given. So R1 is electric lamp 100 ohm, R2 is 50 ohm, R3 is 500 ohm. So all three they were connected in parallel. 1 divided by Rp is equal to 1 divided by 100 plus 1 divided by 50 plus 1 divided by 500. So 1 divided by ohm. So ohm I have taken common factor from these. Okay. So here what I will do, this 1 by 50 I will take it out. Common factor I will take it out. So along with this I will write ohm. So that means here 1 divided by 2 plus 1 plus 1 divided by 10. Okay. Now 1 divided by 50 ohm. This you simplify it. I will take 10 as LCM. 2 5 is 5 plus 10 plus 1. So it will become 16 divided by 500, 50 into 10 ohm. This is 1 divided by Rp. We want Rp. That means just you can cross multiply or just you make just ulta. Okay. So Rp is equal to 500 ohm divided by 16. So we got R. This is the value of R. Now what we have to do? I we have to calculate. I is question mark. So I is equal to V by R. Ohm's law. So V is given. V is equal to 220 volt. So 220 volt divided by R we got. That is 500 ohm divided by 16. So this we have again we have to simplify. I will write here 220 volt into 16 divided by 500 ohm. This is I. Okay. So if we simplify this, you will get around 7.04 ampere. So this is the answer. I. So here he is asking, what are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? So already we have discussed the advantage of connecting electrical devices in parallel with battery instead of connecting them in series. Each appliances get same potential difference. Okay. If one appliance fails to work, other will continue to work properly. So if they are connected in parallel, and the same current flows through all the devices irrespective of their resistances. This is the benefit we got for connecting the devices in parallel. So here, how can three resistors of resistances 2 ohm, 3 ohm, 6 ohm be connected to give a total resistance of 4 ohm and 1 ohm? So trial and error we have to do this question. He has given R1, R2, R3. So R1 2 ohm, R3 3 ohm, R2 is 3 ohm, R3 is 6 ohm. Now he is asking total resistance. You connect these three resistances either parallel or series, but you have to get resistance R. So trial and error we have to do. See, this 2 is there. I am keep it in mind 4. So 2 I will separate. That means one resistor I will connect in series. That is 2 ohm. Because 2 I am keeping it in mind. That's why 2 I separated out. And next 2 I will connect in parallel. That is 3 ohm and 6 ohm. So this is no problem. Only now the problem is with this. This what you have to do. This is parallel connection. Correct? No? So that's why what you have to do. 1 divided by Rp is equal to 1 divided by 3 ohm plus 1 divided by 6 ohm. So you take 1 by 3 ohm as a common factor. So that means here you got only 1 plus 1 divided by 2. Simplify this. 1 by 3 ohm. So 2 plus 1 divided by 2. So which is equal to 1 by 3 ohm, 3 by 2, 2. So 3 cancel. So remaining is 1 divided by 2 ohm. So that is 1 by Rp. Cross multiply this, you will get. So R is equal to 2 ohm. So now this part we got 2 ohm. Correct na? Now you add the resistances. That means R is equal to 2 ohm plus 2 ohm. So you got 4 ohm. Correct na? Then you have to make a one sentence. Connect R1 resistor in series and remaining two R1 R2 resistors in parallel. So this is the answer for question number A. Now B, one more is there. B again we have to answer. So now here he is asking 1 ohm. So 1 ohm means 2 ohm, 3 ohm, 6 ohm. Here also trial and error we have to do. First I will connect all three in parallel. Okay. This is 2 ohm, this is 3 ohm and this is 6 ohm. So 1 by Rp is equal to 1 divided by 2 ohm plus 1 divided by 3 ohm plus 1 divided by 6 ohm. So this what I will do, I will take ohm common factor. So inside 1 by 2 plus 1 by 3 plus 1 by 6. So again 1 by ohm. So this you take LCM 6, 2 3 ja 3 plus 3 2 ja 2 plus 1 is equal to 1 by ohm is equal to this you add 6 by 6 into 1 by ohm. 6 cancel. So that means what we got, 1 by Rp is equal to 1 by 1 ohm. Just cross multiply it, you will get Rp is equal to 1 ohm. So that means R is equal to 1 ohm. So here you have to make one sentence. All three resistances should be connected in parallel. So we got the answer 1 ohm. So that means you have to make a one sentence. All three resistances are connected in parallel.